Let's study the next problem. The mass of imaginary planet is 3 times the mass of the earth. My dear student, here a situation is given to us. According to this situation, it is said that the mass of imaginary planet is 3 times the mass of the earth. Its diameter is 25600 kilometer and the earth's diameter is 12800 kilometer. My dear student, in this problem the diameter of imaginary planet and the earth is given to us. Find the acceleration due to gravity at the surface of the planet is asked to us. Means here, my dear student, we have to find acceleration due to gravity at the surface of the planet. Acceleration due to gravity of earth is given to us and it is 9.8 meter per second square. My dear student, let's try to solve the problem. Let's put all the information which is given in the problem. Let the mass of imaginary planet be mi. The diameter of imaginary planet be di. The radius of imaginary planet be ri and the acceleration due to gravity of the imaginary planet be gi. In the same way, let the mass of the earth be me. The diameter of the earth be de. The radius of the earth be re and the acceleration due to gravity of earth be ge. My dear student, here we have written all the informations which are necessary for us to solve the problem. Now my dear student, here we will write what is given to us. The diameter of imaginary planet is given to us. So di is equal to 25600 kilometer is given to us. The Earth's diameter is given to us, and here DE is also given to us, and it is 12800 kilometer. Acceleration due to gravity of Earth is given to us, and therefore the acceleration due to gravity of Earth, that is GE, is given to us, and it is 9.8 meter per second square. Here, my dear student, a condition is given to us. The mass of imaginary planet, that is Mi, is equal to 3 times the mass of Earth. So we can write Mi is equal to 3 times the mass of Earth, that is Me. So this situation is given to us. My dear student, here we have collected all the informations which are necessary to find the answer. We are asked to find the acceleration due to gravity on the surface of the planet. So Gi, that is acceleration due to gravity on the imaginary planet, is asked to us. Now my dear student, here we know that acceleration due to gravity is equal to capital G into m upon r square. Therefore, we can write Gi is equal to capital G into mi upon ri square, equation 1. In the same way, we can write acceleration due to gravity of Earth is equal to capital G mass of the Earth divided by radius of Earth whole square, that is Re square. Equation 2. My dear student, we have to find acceleration due to gravity on the imaginary planet. So we will divide equation 2 divided by equation 1. So we can write Gi upon Ge is equal to G Mi upon Ri square divided by G Me upon Re square. Gi upon Ge is equal to Gmi upon Ri square. My dear student, here division is given. This division we can convert into multiplication, and then we have to take the reciprocal. So we will take the reciprocal of the next term, that is Re square upon Gme. My dear student, here capital G will be cancelled, and then Gi upon Ge is equal to, we can arrange the formula in such a way that it will be easy for us to find out acceleration due to gravity on the surface of an imaginary planet. So we can write Gi upon Ge, that is acceleration due to gravity on imaginary planet upon acceleration due to gravity on the earth, is equal to mass of imaginary planet Mi upon mass of earth into Re square upon Ri square. My dear student, this we can write in this way: Gi upon Ge is equal to Mi upon Me into Re upon Ri. We'll take it in the bracket and we'll write the square of the bracket. My dear student, here we have asked to find out Gi. So Gi is equal to Mi upon Me into Re upon Ri whole square, and Ge will take to the other side of equation. It is in denominator, that is the division will be converted into multiplication, so we can write into Ge. So here, my dear student, we have got equation number 3. Now, my dear student, here we have arranged the formula in such a way that it will be easy for us to find out acceleration due to gravity on the imaginary planet. So, my dear student, here we have got Gi is equal to Mi upon Me into Re upon Ri whole bracket into Ge. My dear student, here in order to find the acceleration due to gravity at the surface of the planet, there is need for us to know the radius of Earth and the radius of imaginary planet. But my dear student, here radius of Earth and radius of imaginary planet can be find out from the diameter which is given in the problem. So here, my dear student, will take the information which is given. The diameter of an imaginary planet is given to us, that is Di is equal to 25600 kilometer. So from this we can find the radius of imaginary planet, that is Ri is equal to 25600 divided by 2 kilometer. So my dear student, from this we can find out the radius of imaginary planet, and if we solve this, that is 2500 divided by 2, will get 12800 kilometer. My dear student, here diameter is given in kilometer. So we have found out radius, that also in kilometer. But we want radius in meter. So we will convert this kilometer into meter. Meter, kilometer. 1 kilometer, 1000 meter. So 12800 kilometer is equal to x. We'll take the cross multiplication. X is equal to 12800 into 1000 we can write, and this value will be in meter. X is equal to 128 into 100 into 1000 meter we can write. X is equal to 128 into 100 into 1000 meter we can write. X is equal to 128 into 10 square, 100 is 10 square, so we can write 10 square, and 1000 is 10 cube, so we can write 10 cube meter. So x is equal to 128 into 10 to the power 2 plus 3 meter. X is equal to 128 into 10 to the power 5 meter. So my dear student, x is equal to 1.28 into 10 to the power 7 we can write according to scientific notation. So my dear student, what is x? Here we have found out radius of imaginary planet, and radius of imaginary planet is 1.28 into 10 to the power 7 meter. Let's find the radius of Earth. DE, that is diameter of Earth, is given, and DE is equal to 12800 kilometer. From DE we can find RE. So RE, that is radius of Earth, will become 12800 kilometer divided by 2. So RE is equal to, we can write 6400 kilometer. My dear student, here the radius of the Earth is calculated, and as the diameter of the Earth is given in kilometer, so the radius of the Earth will also come in kilometer. Let's convert the kilometer into meter. One kilometer, 1000 meter, 6400 kilometer. X will take the cross multiplication. X is equal to 6400 into 1000 meter. X is equal to 64 into 100 into 1000 meter we can write. X is equal to 64 into 100 means 10 square into 1000 means 10 cube we can write. x is equal to 64 into 10 2 plus 3 meter we can write. So x is equal to 64 into 10 to the power 5 meters we can write. My dear student, here we have to convert this value into scientific notation, and therefore x is equal to 6.4 into 10 to the power 6 meter we can write. Here x is equal to Re is equal to 6.4 into 10 to the power 6 meter. So my dear student, here we have found Ri and Re. That is, Ri is equal to 1.28 into 10 to the power 7 meter. Re is equal to 6.4 into 10 to the power 6 meter. Now my dear student, we have got an equation which is equation number 3, that is Gi is equal to Mi upon Me into Re by Ri whole bracket square into Ge, and according to our formula we have found out the radius of imaginary planet and the radius of earth. And my dear student, now we will try to put all the values in equation 3. My dear student, here G is given to us, Re and Ri we have found out, but Mi and Me we have to find out. But my dear student, here one situation is given, that is the mass of imaginary planet Mi is equal to 3 times mass of the earth Me. My dear student, this is given to us. From this we can find out Mi upon Me. So Mi upon Me is equal to 3. Now let's put all the values which are known to us. Gi is equal to Mi upon Me is 3. So in place of Mi upon Me we will put 3 into Re. My dear student, Re we have found, that is 6.4 into 10 to the power 6 meter divided by Ri, that is 1.28 into 10 to the power 7 meter whole bracket into Ge, and G is given to us into 9.8 meter per second square. So my dear student, here Gi is equal to 3 into 9.8 into bracket 6.4 into 10 to the power 6 upon 1.28 into 10 to the power 7 whole bracket we can write. So Gi is equal to 3 into 9.8 into, now my dear student, here we will remove the bracket we will get 6.4 into 6.4 into 10 to the power 6 into 10 to the power 6 divided by 1.28 into 1.28 into 10 to the power 7 into 10 to the power 7. GI is equal to 3 into 9.8 into 6.4 into 6.4 into 10 to the power 6 plus 6 divided by 1.28 into 1.28 into 10 to the power 7 into 10 to the power 7 we can write. GI is equal to 3 into 9.8 into 6.4 into 6.4 into 10 to the power 12 divided by 1.28 into 1.28 into 10 to the power 14 we can write. GI is equal to 3 into 9.8 into 6.4 into 6.4 into 10 to the power 12 divided by 1.28 into 1.28 into 10 to the power 14. My dear student, this equation I have written it again. Now my dear student, here we have to remove the point. So we can write GI is equal to 3 into 98 into 64 into 64 into, my dear student, here one digit and one digit, total 3 digit we have to remove. So when we remove 3 digit, we can write 3 into 98 into 64 into 64 into 10 to the power 9. In the same way, my dear student, here we have to remove the point. 2 digit we have to remove, again 2 digit we have to remove, so total 4 digit we have to remove from the denominator, and therefore we can write it directly 128 into 128 into 10 to the power 4 digit we have removed, so we will write 10 to the power 10. GI is equal to 3 into 98 into 64 into 64 into 10 to the power 9, and in the denominator it is 10 to the power 10. So this 10 to the power 10 will go up, and we can write 10 to the power 9 minus 10 upon 128 into 128. GI is equal to 3 into 98 into 64 into 64 into 10 to the power minus 1 upon 128 into 128 we can write. Now my dear student, here 64 1s are 64, 64 2s are 128, 64 1s are 64, 64 2s are 128. So we can write GI is equal to 3 into 98 into 10 to the power minus 1 divided by 4. So my dear student, GI is equal to 3 into 98 divided by 4 into 10 to the power minus 1 we can write. Now my dear student, here if we multiply 3 into 98, we will get Gi is equal to 3 into 94, and 3 into 94 we get 294 upon 4 into 10 to the power minus 1. So we can write Gi is equal to 294 divided by 4, we will get 73.5 into 10 to the power minus 1. Now my dear student, this value we have to convert into scientific notation. So we can write Gi is equal to 7.35 meter per second. So my dear student, here we have found the acceleration due to gravity on the surface of the imaginary planet, and it is found to be 7.35 meter per second. So we can write the acceleration due to gravity at the surface of the planet. The acceleration due to gravity on the surface of the planet is 7.35 meter per second square.